Now entering the Bitcoin Podcast Network.
Ether is the perfect drug for Las Vegas. In this town, they love a drunk. Fresh meat.
Come on, buddy.
So they put us through the turnstiles and turned us loose inside.
Hello and welcome to your weekly dose of Ether. It's been a few weeks now since we've had our normal show. This is lucky episode 13. Today, Lucian and I are going to talk about scaling Ethereum, both the foundation, we're going to look at the roadmap, and also just generally discuss Ethereum versus other platforms. Will it survive until 2.0? So let's just get started. Lucian, what's new with the scaling debate around Ethereum and smart contract protocols?
So the scaling debate, now Ethereum 2.0, instead of being colloquially termed as Shasper, sharding plus Casper, dumb name, as they agreed to call it Serenity, as it was originally intended. And what ended up happening was basically they're just going forward with some of their original plans. Proof of stake is the first and most obvious, both for environmental reasons, but also potentially throughput and security reasons as well. But then there's sharding. And to explain what sharding is, it's like basically having multiple parallel blockchains that agree on a single data set. So it's like having multiple chains running in parallel, which in my opinion is going to be one of the most difficult tasks to implement. And it's even questionable whether or not it's necessary, but sharding is how traditional databases scale. On the flip side, traditional databases are usually capped at around 10 massive data centers worldwide in the most extreme cases. And the reason for this is that the communication between all of these various data centers has to even out, and they all have to agree. So traditional systems have usually relied on informing every other data centers of the change of the data in a particular data center.
Yeah.
Doing something like this with a blockchain doesn't work because of the latency and because of the communication and network overhead. So how Ethereum implements this is, first of all, just a massive technical challenge, and some people actually doubt whether or not it's possible. I personally think that there is a good way to implement it, but they just haven't gotten there yet.
Sharding is not a new technology, right? And just like you're saying, in traditional web products, you're going to have sharded databases, and that's going to improve performance and reliability and all of these other things. In blockchains, this is totally unproven technology and really hard to execute in practice. And there's a lot of doubters, of course, but whether or not it's feasible, it remains to be seen. I guess the question I have is, how long is it going to take before we prove that out, and what is the impact on the ecosystem in the meantime?
Right. What is the impact on the Ethereum ecosystem or on the whole blockchain ecosystem? Because in my personal opinion, I think the plurality of experiments is going to help the entire ecosystem as a whole. And including something like sharding into a major blockchain like Ethereum, I think will essentially push the boundaries of what's possible. So if they do accomplish it, then it's basically going to set a new high watermark and prove what is actually capable.
There's that argument, and the question that I have then is it relevant at all? What is the impact of not getting sharding? There are many teams that are not even pursuing sharding as a scaling technique. And so obviously you've got the Bitcoin caches who are looking at increasing block size and other techniques, right? and those are more traditional. You have state channels, which haven't yet been proven out, but maybe that's the appropriate scaling mechanism for the time being. Why is sharding even necessary? Can we get to the scale we need to without it? And it looks like a lot of companies or businesses are betting on that. Tezos, for example, doesn't have a sharding plan. They're thinking that ZK snarks or Starks are the way to scalability. I mean, there's so much research happening. How do we know that a very complex model like sharding is going to be the right one for the future?
So I actually do hope that people come up with alternative solutions to sharding, and the entire blockchain ecosystem isn't dependent on this one development task to progress and increase usability and throughput for their respective networks. But I think sharding got into the picture because that's how traditional databases scale, right? So if it's possible to be done on a traditional database, and that's one of the avenues with which it improved throughput, then arguably, why shouldn't a blockchain be able to do it too? It also helps when there's a lot of research, when a lot of people have made livelihoods out of improving existing systems and then incorporating that into a modern system, essentially not dependent on technology that isn't ready yet. For example, the use of snarks, is used in Zcash, currently produces something called toxic waste. So you have to make sure that all of the cryptographic keys generated for this ceremony are thrown away, which is why people prefer to use something called Starks. And Starks simply aren't ready yet. They haven't actually achieved the necessary improvements to be used as in a practical system like Zcash, for example. So if you're dependent on a breakthrough in cryptography to actually start implementing the changes that you want now, then you're not really going to be able to do anything until those breakthroughs happen. And the idea that it's going to happen on a random blockchain project rather than at a research university that has improved the mathematics behind certain cryptographic algorithms is kind of unlikely.
I mean, I don't know. Let's take this. I'll take the counter argument to that. We don't know that sharding is proven in the context of blockchains and that it can work. I mean, it's taken them 3 or 4 years to come up with a plan to get to proof of stake from proof of work with Ethereum, and now they're including sharding. That's a complexity on top of complexity, never been done before, and it's not clear to me that it's necessarily the right timing. Maybe the best approach is to hold back and not pick a direct, a big change right now, not commit to that, because here's the problem, is that Ethereum is having a little bit of a governance problem itself. You have Vitalik and Vlad, who are kind of the in many ways the visionaries and the people that others point to as setting the direction. And these guys are very into the future. They're focused on how can we scale to 10,000x and how can we be World War III resistant, when other people are like, hey, we're not even hitting the cap of Ethereum capacity today. Why do we need to be resistant to World War III? And if it takes 3 or 4 years for us to get that vision, even tested and live in production, what has occurred in those 3 years that may be a faster path? And then the other question that I have is, maybe we don't need that level of scaling for 10 or 20 years. So how do we know that we're even at a point where we can commit to a roadmap?
There's a couple of things to kind of untangle there. And I think the first one is building something that is resilient to World War III. So that's something called the random beacon research. And essentially the Ethereum Foundation proposed an idea of hardware modules that they're custom building and disseminating to several thousand people around the world that are going to do something like a proof of work equivalence, but it's like proof of time computation or something like that.
Yeah,
Essentially,
verifiable delay functions, VDFs.
Exactly, yeah, thank you. And essentially, what they're doing is that they're introducing a random beacon into a blockchain. And when I first heard this is actually being implemented within the Ethereum ecosystem, my first reaction was, damn, Dfinity is going to be really pissed because they have a random beacon chain. And essentially, what the Ethereum Foundation is doing is taking a hardware solution to the basic premise that their blockchain was built off of using pure software. And if people aren't familiar with Dfinity, I would definitely look it up. It's a very interesting blockchain, but it's the idea that you technically don't need to store all of the data within a single data structure. Instead, what you can do is you could do the random beacon and create a series of like data proofs that show and can prove that that a piece of data was inserted into the chain during a specific time, right? So it's a very interesting model. It's a bit different than the Ethereum model by quite a bit. And it has some really interesting scaling properties because it changes the amount of data that actually needs to go on chain. It also improves the development of layer 2 blockchains. And I think there's a lot of interesting outcomes out of that. I actually don't know how they're using random beacons in Ethereum 2.0 yet, but it seems to be somewhat connected.
Yeah, I mean, I think, and I'm not as well versed in this as many people are, but the random beacon, is going to be a service not only that the primary, blockchain leverages, but also others, app developers could use as well. And developing a random number generator is actually a very non-trivial problem. But once you have
on a blockchain, it's really difficult.
And once you have it, it's very useful. And so I think in the Ethereum 2.0 context, there's a lot of potential areas that it could be used. I don't know that it's finalized, but picking validators if you wanted to do it randomly, or picking, but the random beacon that they're building, I understand is meant to be kind of on the side, right? That would be the first kind of proof of, or that would be the first system developed as outside of the main Ethereum network, and it would work essentially to start that roadmap of Ethereum 2.0 without building everything and releasing it at once. And it proves out a lot of those concepts that they want. But it's not clear to me, even if they do leverage this random beacon to eliminate some of the data that is stored in the blockchain, there are other ways to do that too. And zero knowledge proofs kind of open the door to a lot of other mechanisms to saving the weight of the blockchain.
Yeah, I actually really like the potential of zero knowledge proofs to reduce the weight of the blockchain. And as you mentioned, there are many, many different angles at which you can approach the same problem, which is the fact that you just can't put all of the data in the same data structure and expect the entire world to use it in an efficient way. And I think the development of zero knowledge proofs and Zcash, who really put it into the first production application, has been a major innovation. It's really opened my mind to a lot of potential possibilities, but at the same time, it also really opened my mind to how vulnerable, from a privacy standpoint, all existing blockchains are. And the funny thing is that maybe with zero knowledge proof implementations to improve scaling, you could also get better privacy and security guarantees.
Absolutely.
And yeah, that's why I'm also very, very hopeful for solutions like that in the future. But they're not ready yet. And all of the I noticed that in a lot of discussions between the Zcash community and the Ethereum community, they found a lot of points of similarity. And recently, they started like interacting very closely. Zcash had multiple um, talks during DevCon, which is the Ethereum Developer Conference. And at one point before the conference, Ethereum and Zuko, the two basically leaders of these separate blockchains, actually like postulated the thought experiment of what it would mean to merge two blockchains, like merge their communities, because it'd be amazing if Ethereum had support from the amazing cryptographers on the Zcash team, and Zcash would greatly benefit from the largest developer community in the blockchain space. And yeah, I mean, some really interesting points came out, and it's the fact like you can't just merge two blockchains, because then you would essentially create three blockchains, right? There is always the possibility of people just continuing the native chain without um, accepting whatever new token was created in trying to merge and reconcile the two networks. But anyways, I hold my fingers crossed and hope that the first blockchain merger, first of all, will be a merger of a smart contract platform and a zero knowledge proof privacy preserving blockchain just merge together and just perform some amazing kind of superpower world changing stuff that we've been hoping.
I mean, you get those two teams together, that would be something else. That would be quite the headline and probably drive price action. But there's something interesting.
They actually are together. So, for example, Parity is now hired to implement the second Zcash client. So, Parity is the second leading Ethereum client implementation, and it's a company that was started by the former CTO of Ethereum, Gavin Wood. They're also the guys behind Polkadot, and they're building a Zcash client, and it's for the express reason that they want to learn the actual like intricacies of zero knowledge proofs.
Yeah.
So that they could hopefully integrate it into Polkadot or Ethereum.
Hopefully both. I mean,
Yeah.
I love. You make a really great point about using zero knowledge proofs, whether it's ZK snarks or starks, to as an added benefit of scaling is leveraging it for privacy improvement. And I think from the Zcash perspective, they're doing a lot of fundamental research into how to get privacy, but ultimately it fails if these are not adopted in the main blockchains that people are using. And I think there's a fear that if we don't build privacy into the core of our next generation payment mechanisms, that we're going to have a big problem, and it's going to be even harder to implement it later. And so jumping on this now not only has potential scaling benefits, and huge ones at that, but also starts to build in the privacy as a base principle in blockchain transactions into the future before the next bull run, before mainstream adoption happens.
Yeah, it's just so new, and it just feels like magic. The entire concept behind zero knowledge proofs is kind of mind-bending and almost a little too difficult for me to try to explain on record, but I'm going to foolishly try anyways.
I think we can break it down a little bit and get some insight on it.
Sure. So the most common analogy that I've heard is imagine you have a Sudoku puzzle, and you want to prove that you have an answer to the Sudoku puzzle but you don't want to reveal what the answer is to the grader, correct? So what you do is he randomly asks for a line, and then you create a like, let's say you multiply that line by 10, right? And then he doesn't know that you multiplied it by 10 or some other random number, and it actually changes the values that you submit, but it's a change that's in a way proportional to the real answer. So then he's going to ask you, like, okay, he asks you for another line, and it's another multiple away from what you actually have, right? So he asks for like the fifth row, and you multiply it by 7, another random number. And it follows certain properties, and you can prove that the encrypted data follows a rule set without revealing what the unencrypted data is, right? So that's
interesting.
Yeah,
and
succinct, non-interactive argument of knowledge, I think, is what a ZK snark is. Zero knowledge, succinct argument of non-interactive knowledge. And the idea being that the grader can never recreate the Sudoku puzzle answer that you have, but he can check that it followed the rules of what a Sudoku puzzle is. And if you do it repeatedly, it becomes nearly impossible to fake knowing the right answer without actually having the answer.
Right. And so I guess to bring it into the blockchain world with like a simple transaction, a balance of tokens from one person to another, in a zero knowledge proof, what you would do is instead of submitting the transaction itself, like I'm sending 10 tokens from Alice to Bob, you would instead submit the change in balances. So, minus 10 on Alice and plus 10 on Bob. And you would submit a proof along with that can be validated by very efficiently and in just a few milliseconds. And the idea being is that you don't have to say that Alice gave Bob money. You just have to say that Alice lost money and Bob gained money. And you can prove that this happened without actually saying that Alice moved it to Bob. And this can happen with any kind of complexity of transaction. So you could imagine an entire smart contract or an entire distributed application. Essentially, the people performing the action, the agents, are doing the computation themselves, and they're wrapping it up in this proof that shows that that anyone can validate is legitimate, and others can verify against. And so it could be hours of computation that's being done on a separate computer with a tiny little proof that you can submit to the blockchain that anyone else can validate that whatever you did in that compute, they can pick out one particular transaction, and without them knowing the rest of the history of what happened on your computer off chain, they can test you and challenge you and say, hey, do you know about this balance change? Do you know about this one? And every time you can submit a response that you can get an answer of yes, this happened, without actually seeing the data behind it and parsing it out yourself.
Yeah, it's fascinating that it's even possible. It does feel a little bit like magic. And like, even one of the things that makes this possible, which actually surprised me when I first heard that it was, is being able to do computation on encrypted data. So imagine you have a key and you encrypt the number 10, and it turns into 256 bytes of random bits that are indecipherable from the number 10, except it's possible to actually execute computation on your encrypted data so that I could multiply it by 2, and then you could decrypt it and get 20. and I am the one performing the transformation of your encrypted data, but I never have your key and I never know what the data is underneath.
This is super powerful, right? Because we have a lot of organizations. I think there's a number of them that are trying to do decentralized compute, right? And then the question is, how do you outsource computation without revealing the data that you're trying to get computed? Because most often you're trying to protect your intellectual property. You want to, let's say, build a neural network, and you want to use 1,000 different computers that you don't have, you know, access to yourself, and so you outsource it to, let's say, a distributed network of computers to do computation. But now you have to reveal your algorithm for them to perform computations. And the question of how you actually parallelize this to make use of 1,000 different nodes is a big problem. And so many of these protocols have focused on one particular application. So they're like, okay, I'm going to focus on 3D modeling for, you know, video games, and we're going to do one algorithm that we're going to help. But zero knowledge proofs, it sounds like, would be a more generalized way of doing computation outsourcing to a distributed set of nodes. Is that right?
Not necessarily zero knowledge proofs, but the concept of doing computation on encrypted data is part of something called homomorphic encryption, and it exists. Although theoretically no one believed that it exists until very recently. It exists, but it is computationally inefficient. And there's actually a blockchain project who's leading the way. Shout out to New Cipher. They're doing really interesting work, and they actually did homomorphic encryption on the Ethereum blockchain in a smart contract. So they also have really like cutting edge libraries that cut down the amount of time required to do homomorphic encryption, because it's just very computationally intensive. I can't pretend to know why or the mechanisms underlying it, but they actually have a library on their website to GPU accelerate homomorphic encryption. And yeah, exactly. I agree with you. It is kind of the holy grail of secure data transfer, because if, as a cloud provider, you never need to decrypt data, then you have individuals and users who can actually manage their own private keys. And imagine all of the pictures that are stored on Google Cloud. Google doesn't have the ability to decrypt the content of the pictures. That would be ideal. It would be basically what most people would want. At least that's what I assume. It's just...
I mean, you could take that idea even further in a way, and you know, you may even be able to allow Google to run their neural network and optimize, you know, click-through rate. Or let's say you wanted some valuable service that Google offers, where they tag your photos so that it makes your photos searchable. Well, if you have private access to your photos, how can they build a neural net, you know, and use machine learning to train a data set to build that label, to create a label for your photo? Let's say it's a picture of you hiking. How can they tag that with hiking if they never see the photo? But it sounds like you could use this mechanism too to extract maybe useful signals from the picture, like that there's a bike and riding on a hill, or like there's a guy walking on a mountain top or something like that, without actually seeing the data behind it. Would that also be possible with this technology?
Eventually. Currently, it is, because the rate of computation grows at such a fast rate compared to the number of computational steps that you have to take. It is very difficult to do anything practical outside of basic arithmetic and expect your computation to finish within your lifetime. So the rate at which, like, the amount of time and processing power that it takes to actually run these computations just explodes. and it's still pretty much impractical to use for anything except like key transformations, which is what NuCypher is doing, or specific proofs that a coin has been spent and another one created in the UTXO model of Zcash. Like, they're very specific and limited use cases for now, mainly because it's very new, right? So Zcash was launched 2, maybe 3 years ago, and it was the first implementation of a zero-knowledge proof system in production. So who knows? I am there. Actually, NuCypher also uses zero-knowledge proofs to ensure that people within their network correctly decrypted correctly performed the key transformation in their network. So they're using it for a decentralized key management system rather than having your private keys managed by like Azure Access Control or something like that, like a central key repository. Instead, you would have to send a request to the NuCypher network, and they would perform transformations on pieces of your key, send it to you, and you would complete the transformation and then decrypt it, and you would have a decryption key. And the uses of, and in my personal opinion, like, I think that's actually one of the most efficient ways to have a one-to-many encryption scheme with Ethereum currently. So it's interesting, even though it does use zero-knowledge proof, because it uses it in like a very specific niche context, you can still have like a lot of efficiency if used correctly.
Yeah, and I mean, like you said, a lot of this is just now being used, and it doesn't have the transaction volume, or there's not so many people using it, so I don't know that we can necessarily rely on this for production level services quite yet, but this is definitely the direction things are going. Another interesting thing is that the progress being made on verification times and compression, with Mimblewimble as an example of improvements to compression while trying to preserve privacy. You could argue whether it does or not. And then the other thing is that I think these are inherently quantum resistant, if I'm understanding correctly.
So Starks are supposed to be, but Snarks not necessarily.
Right. So in any
but
case, it
I
sounds
think
like we may need to wait for quantum compute to be able to run this software. But I think building the algorithms now and testing it out, even if it is for simple arithmetic, gets us to that point, because it took 30 years before we had the data, bandwidth, and compute to be able to do, autonomous driving. But many of the algorithms were built, in the 70s and 80s. So this might be another one of those things that we're going to keep banging our heads against it until we actually, hit the holy grail.
So I also want to point out that there is a research paper published by a lot of the core developers, plus some other researchers in the Zcash community, that proposes a smart contract platform that uses zero-knowledge proofs. And the research paper is called ZEXE, Enabling Decentralized Private Computation. And I'm pretty excited. I think the potential of having secure and private compute, I can't imagine the extent of the use cases that could come out if Ethereum was also privacy preserving.
I mean,
definitely excited.
We'll have to see.
Definitely remains to be seen if it can be built. Theoretically, it can.
Yeah, let's talk about the foundation and how it's handling this from like a governance perspective, because it seems like the roadmap has changed a lot. There's now there's talk about a 1.x that is going to be the next upgrade. We've kicked the can down the road with regards to the difficulty bomb. POS doesn't seem to be any closer, although we do have a lot of progress from 7 or 8 teams building this spec, but the spec also is changing, and it's unclear, how Ethereum as a project is going to fare against the rapidly incoming competition. So, what is there anything wrong with the governance of Ethereum today, in your view?
In my opinion, the Ethereum Foundation is a little overstretched. I think that, I'm basically saying that in the last 2 years that I've watched it, they actually haven't really gone through a reorganization, despite the fact that there has been a multiple, like X number of people that the foundation is supposedly serving. I'm not saying like the developer community is directly being supported by the Ethereum Foundation. I'm just saying that the number of people using the platform, the number of people interested in the technology has just grown at such a large rate. Yet the Ethereum Foundation itself, organizationally, hasn't made a lot of changes. So my parallel would be, imagine having a company like Consensus. This is a relevant example that basically grew from like 200 people to 1,000 people. And after they grew that much, they realized like, oh crap, we're not the company we used to be. It's like, yeah, you're a 1,000-person company now, so you have to start acting like it. And I think the same has happened to the foundation as well.
How many employees does the Ethereum Foundation have? And, obviously their big stash of Ether has devalued quite a lot since January, but where do they stand?
I'm not necessarily concerned about like the actual employees so much as the way that they approach their fundamental mission, which is actually to decide upon the direction that the software itself is developing, right? So it's not necessarily that the staff hasn't grown. I don't expect them to have a customer service department or anything else like that. It's just that their actual decision-making processes that grew up in a self-organizing open source development community actually haven't changed. And most of the most powerful decisions are made in all hands calls. And a lot of these all hands calls are actually open to anyone to join. And then you basically have these developer-based like consensus by default. Whether or not someone speaks out during one of these calls actually decides the future development decisions that the entire community is going upon. And these are basically, from what I understood, being judged by one guy who's essentially moderating all of these conversations. And he basically feels the pulse of developer decisions and basically says, okay, that's decided, no one disagreed, all right, we'll move on to the next feature.
Right? And that's I don't know, there's two sides, there's probably a lot of ways to look at this. On the one hand, the Ethereum Foundation should be able to disappear and it have zero or minimal impact on the direction of the protocol because it is driven by users, miners, and developers. If you could take that point and extend it to the development community itself, if they have rough consensus and this guy gets the pulse wrong or whatever, and there's actually a big segment of the user base that doesn't support a change, well, they're theoretically going to fork off, and that's what happened with the ETC fork. The question is, are people really informed enough about these changes and how decentralized really is that roadmap development? I think Vitalik and others got a lot of flack for publicly saying that they don't want to be in the face of they are not the face of the protocol, that Vitalik doesn't make all the decisions, but then they have these closed door meetings and reveal a spec or a draft of a discussion. There's two sides of that. You can't just have a democracy and thousands of people contributing to something that's not really ready for public consumption. can you have all of this research and development done out in the open? Maybe not. Maybe you do have to have small groups meeting together, figuring things out, and then presenting it to the rest of the community. And what are we going to put what avenues are not already there to govern this protocol? Does the Ethereum Foundation really need to change at all? It's not meant to be consensus.
Right, but at the same time, so I actually never really understood how protocol level changes happened at Ethereum until I watched a podcast between Gav Wood and Vlad Zamfir on the Zero Knowledge podcast series. And the first thing that I noticed was the fact that Ethereum doesn't actually have a process. Yes, they do have certain people who are able to push code into the main repositories, but the process behind actually proposing changes outside of like the Ethereum improvement proposal process is essentially getting core developers to argue your case for you, right? So like if you actually have a research initiative or idea that you want essentially to become mainstream or adopted and change the way the protocol is implemented, there's no formal process for your idea to get heard. So you have to realize that not having a process is a process, right? So let's say you're in a decentralized organization, and let's just pretend this is a hypothetical organization, and everyone works remote. People very rarely meet all in the same place, and they have this kind of like work on whatever you want, like put your time, like put your effort towards whatever project you want to put your time and effort towards, but you all have supposedly the clear same end goals, right? And this could be represented in the protocol spec, or it could be in some like high level research implementation that you're trying to implement. But when it comes time to actually like make a decision and try to understand the direction that the organization is going, then it's really hard to steer a ship if you don't directly have access to one of the key decision makers whose voice can get replicated within the ecosystem so as to actually direct the course of the ship.
Yeah,
right? So this is what I'm saying. Like by not having a process, you become more centralized because you rely on the social media accounts of key developers to actually propagate new ideas because you don't have the process. Right. So
yeah, I mean, it's hard to see clearly what the right approach is. I mean, democracy itself is, it's very messy, right? But it's also very useful. So, I mean, everything is a lot smoother in an authoritarian government where you have total control, but there's downsides to that, right? And in the case of the blockchain space, having too much process is exactly the thing that the core developers of Ethereum think is detrimental to the protocol long term. They're very against the on-chain governance mechanism of Tezos or any other system that's trying to create a rigid process around governance, because they know that forking is governance, and communities that stay together are ones that tend to have consensus, and when they don't, they will split. And the view is that it's simple, it's messy, and it works, and leave it be like that. If it's important enough to get a process and a proposal system in place, then the community should build it, and the core developers should adopt it. And if they don't, and people care about it enough, they should fork, right?
Right. I mean, I agree. And currently, that is the modus a priori of the Ethereum Foundation. And basically I've heard of cases in which it's just like, yeah, you're gonna have to fork Ethereum if you want that kind of change, and like, okay, cool, but the other aspect of it is that this isn't actually a democracy. There's a really interesting article by Hasib that basically that has the title "Blockchain Isn't a Democracy, and That's a Good Thing." But basically, I want to reiterate the fact that real democracies almost never exist. Currently, we live in a representative democracy, which means that we elect people to represent our beliefs. And the reason for this is that basically we use a proxy to represent our interests in a like parliamentary system. And
I mean, yeah,
in a way, there's not an easy way to have an analogy in a blockchain space, because there's no way you could have one person, one vote, right? And no one really wants to fall to the one coin, one vote system either, right? Because then you have a different kind of autocracy in which you're ruled by a small clique of early adopters, investors, and founders. So that doesn't make sense either, right? And at the same time,
yeah.
maybe technical decisions shouldn't be made democratically. But I think processes themselves are going to become more and more important when you have new people entering the space that don't necessarily have the clout, but having a democracy of ideas is what we want. We want basically like the results of a democracy, an idea meritocracy. I've heard it called before.
Yeah.
And it's really hard to actually get the organizational culture right. And I just get the feeling that maybe the fact that the Ethereum Foundation hasn't really changed or tried to change in so long, that actually might be a major risk in the fact that having new ideas, like being open to questioning certain directions that they're taking, and basically saying like, oh, if you don't like the direction that we're taking, regardless of the facts that could be brought up during a formal process, well, you can start your own blockchain and do something else, right? Because there is no guarantee that they've actually picked the right course of action. And the idea of an idea meritocracy is that ideas have an equal and level playing field to compete against each other. But in Ethereum, I hear a lot of people who don't really have like a platform to speak on, but there's other people whose ideas greatly outweigh anything that has come about. This is just something like for me that I've found difficult because it's hard to keep up with the space. There's no authoritative news source. There's no way to keep up to date. The research presentations are pretty disorganized and rambling in its structure. So it's really hard to like get to the tip of the spear in any issue. And every time I do have like a fundamental doubt about a direction, it might just be that I just don't have the full story. But it's also really difficult to basically propose an idea, have it heard by the community. It's yeah, and that's mostly an organizational change issue.
I mean,
right?
I don't know. I am sympathetic to the view that we shouldn't put too much process in place, because the process being rigid is itself a kind of tyranny, right? And these are blockchains that are meant to be, to not rely on any counterparty to get things done. And the more that we rely on systems to go a certain way, to be done in a certain way, that kind of process is kind of the antithesis. Everything should be on all the processes that you build should either be on chain or open-ended. And I think we've been dealing with this for hundreds of years in traditional government, and we're going to start to see the tyranny of blockchain governance here in the future. And I guess we'll have to see how it plays out. But I am leaving it open. I don't know which type of governance is going to prove out to be the best and most sustainable long term. But for 10 years, the hard fork and soft fork idea with limited process has been working. So I
Cool.
wouldn't mind betting on that. I think in the end, this debate is open, and we'll carry it on for another day. But
Sure.
you know,
Yeah, I want to close with the question that essentially like clearly identified the differences between Gav's and Vlad's basic idea, and it's, do you actually think that we could implement an on-chain DAO that could actually govern the blockchain in which it's on?
it's a big question. We'll have
Yeah,
to stew on that for
right?
a while. All right.
Yeah,
Well,
I'm undecided as well,
Yeah.
but I'm hopeful. I just know it's not ready yet. So,
all right. Well,
if I can pick a middling answer, that
Yeah.
that would be it.
yeah. Well, we'll leave it there. No cliffhanger. So thanks so much to everyone who's listened for today. We'll wrap up this episode. Thanks to the Bitcoin Podcast Network for publishing, and we'll see you next time.
Great talking to you.